Now the next is geometric series. The series corresponding to a geometric progression is called geometric series. That is, if first term is A and common ratio is R, then corresponding to nth term of GP series is sum of nth term of GP, that is geometric progression. Therefore, Sn is A plus AR plus AR square up to AR n minus 1. So this is the geometric series of n terms, and we will prove this result by stating the theorem 6, and we will prove this result, that is Sn sum of this series is equal to A into Rn minus 1 over R minus 1 by principle of mathematical induction. So that statement is theorem 6. If the first term of a GP is A and common ratio of GP is R, then the sum of first n terms is Sn is equal to A into R raised to power n minus 1 over R minus 1, where A is not equal to 0, R is not equal to 0, and R is not equal to 1, otherwise it becomes infinity, and n belongs to natural number. And Sn is equal to Na if R is equal to 1. We will prove this theorem by use of principle of mathematical induction. That is proof So as we are going to prove the above result by principle of mathematical induction, thus we assume let Pn is equal to Sn A into R raised to power n minus 1 over R minus 1, where A is not equal to 0, R is not equal to 0, R is not equal to 1, and n belongs to n. And S of n is equal to n times A if R is equal to 1. So this is our statement Pn, which can be proved by using principle of mathematical induction. So the first part, for n is equal to 1, P of 1 is S1, which is equal to A, R minus 1 over R minus 1 gives A, that is first term of GP. Therefore, result is true for n is equal to 1, as h1 is same as a. Now we will assume result is true for n is equal to k, that is p of k, that is sk, a into r raised to power k minus 1 over r minus 1, where a is not equal to 0, r is not equal to 0, r is not equal to 1, and k belong to n. And now we have to prove result for n is equal to k plus 1. That is, we have to prove s of k plus 1 is equal to a into r raised to power k plus 1 minus 1 over r minus 1 for a is not equal to 0, r is not equal to 0, r is not equal to 1, and k belongs to n. Now, as we know that s of n minus 1 is equal to an, therefore s of k plus 1 minus sk is equal to tk plus 1 a term. Therefore, s of k plus 1 is equal to s of k sum of k terms plus tk plus 1 a term. So we get, as result is true for s of k, therefore from number 2 we get a r raised to power k minus 1 over r minus 1 plus k plus 1 a term is a r k plus 1 minus 1. So we get a into r raised to power k minus 1 over r minus 1 plus a into r raised to power k. So on taking LCM, we get r minus 1 as LCM in the denominator, and in the numerator we get ark minus a plus ark into r is ark plus 1 minus ark. So if we see a into r raised to power k is positive minus ar, this will be cancel out. These two terms are equal. This is minus ark. So we get a is common out, and r raised to power k plus 1 minus 1 from these two remaining terms over r minus 1. So if we see, this is the result we want to get. So pk implies pk plus 1 is true. That is, by principle of mathematical induction, result is true for all n. Now, if we have r is equal to 1, then Sn becomes a plus a into 1, a into 1 square up to so on. ar, here r is 1, a1 raised to power n minus 1. So 1 raised to power something is 1. So if we see, there are n terms starting from 0 to n minus 1. Therefore, S of n is equal to n times A. Therefore, we get Sn is equal to A into r raised to power n minus 1 over r minus 1 if r is not equal to 1 and equal to n times A if r is equal to 1. So, this is a sum of GP series of containing n terms. Now we will do problem based on GP series. For a GP, if T2 is 6, that is second term is 6 and fifth term is 48, then find sum of 6 terms. As we have T of 2 is equal to 6 and T of 5 is equal to 48, then T of T means 2 means AR is equal to 6 and T of 5 means AR raised to power 5 minus 1 is 4 is 48. This is number 1, this is number 2. So dividing 2 by 1, we get that is A into R raised to power 4 over A into R is equal to 48 over 6. So, on cancelling the same factor, we get R cube R raised to power 4 into R raised to power minus 1, that gives R cube is equal to 8. 6 8s are 48. Now again, it is cube root of 8 and it gives real root as R is equal to 2. So we get R is equal to 2. Now we have to find A. As we have A into R is equal to 6. So it gives A into 2 is equal to 6. That gives A is equal to 3. So we get A and R. Now we have to find S6. That is A into R raised to power 6 minus 1 over R minus 1. So here A is 2, A is 3, R is 2, 2 raised to power 6 minus 1 over 2 minus 1. So we get 3 into 2 raised to power 6 is, that is 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32, 32 is 64. We get 64 minus 1. So we get 3 into 63, that gives 189. So sum of 6 term is 189. Now the next problem is the third term of a GP is 3 by 4 and the sum of first 5 terms is 32 over 33 times the sum of first 10 terms, then find the sum of first 4 terms. Now here we have two conditions, that is third term is 3 by 4 and that gives A into R square is equal to 3 by 4. That is number 1. And second condition is sum of first 5 terms, that is S5, is equal to 32 over 33 as 10. That is, by the formula of sum of series, A into R raised to power 5 minus 1 over R minus 1 is equal to 32 over 33 A into R raised to power 10 minus 1 over R minus 1. From here we get AR cancel out, R minus 1 is cancel out, and we get R raised to power 5 minus 1 over R raised to power 10 minus 1 is equal to 32 over 33. And if we see, we can rewrite R raised to power 10 as R raised to power 5 whole square minus 1 square is equal to 32 over 33. That gives R raised to power 5 minus 1 over R raised to power 5 minus 1 into R raised to power 5 plus 1 is equal to 32 over 33. That gives 1 over R raised to power 5 plus 1 is equal to 32 over 33. That gives 32 R raised to power 5 plus 32 is equal to 33. That gives 32 R raised to power 5 is equal to 33 minus 32. So we get R raised to power 5 is equal to 1 over 32, that is equal to 1 over 2 raised to power 5. That gives R is equal to half. As we get R is equal to half, now we can find from number 1 the value of A. Therefore, from number 1 we have A into R square is equal to 3 by 4. That is A into 1 by 4 is equal to 3 by 4. That is A is equal to 3 by 4 into 4, that gives 3. Therefore, A is equal to 3. As we get A and R, now we can find sum of 4 terms. Therefore, as 4 will be A into, as R is less than 1, it becomes 1 minus R raised to power 4 over 1 minus R. Now we substitute the value of R here. A is 3, 1 minus half raised to power 4 over 1 minus half. So we get 3 into 1 minus 1 over 16 over 2 minus 1 over 2. So we get 3 into 16 minus 1, that is 15 over 16 into 1 over 2, it becomes 2 over 1. So we get 45. 5 into 3 is 45 and 2 into 8, we get 45 over 8. Therefore, S4 is 45 over 8. So these were the problems based on geometric series.